Okay. Good evening, class.
Good evening.
Uh, the last time we studied about data SQL. Today we are going to read about, going to learn about database management system. Yes, I'm going to take a roll call and hope everybody's in. Sharon,
Present.
Maulin, are you present?
Present.
Laurin,
I'm present.
Bernard.
Present.
Okay, I see everybody is present. So today we are going to learn database management system, and at the end of the lesson, I'm expecting us to be able to understand what's database management system, its components, and the database design models. So I hope everyone can see my screen, my presentation.
Yes.
So what's database management system? Who has a clue about it? What database management system? Bernard,
DBMS, a software system that enables users to define, create, maintain, and control access to database.
that's a good suggestion, and he has gotten it. So it's mainly a software that enables users to define and create and maintain and control access to databases. And the major functions of a database is just the storage, to retrieve and modify and deletion of the data that is stored in the database. So in modern days, today's modern applications, they facilitate efficient data management, which also enhances security and data integrity. So also we want to look about components. Since we have known what's DBMS, we have to know what's the components of the database. So Lauren, who has a suggestion about who knows about the components of DBMS?
One component of DBMS is the database engine.
Yes, that's a good suggestion. Anyone who has a clue about it? Okay, so majorly DBMS has a for components database engine, which is responsible for managing the storage and getting the data and even modifying it. There is also a component for query processor, which queries the database to get different data, and it's optimizing data retrieval. Then there's a transaction manager and a concurrency control. So that's majorly about the components. Next, we look at the types of DPMS. We have four of them. Who has a clue about, who can tell me types of DBMS? James?
We have a relational database or relational DBMS. This is a database organized in columns and rows.
Good, that's a very good suggestion. Relation database which organizes tables into rows and columns. And any other? person, any other student with okay. So the other types of DBMS include the object-oriented DBMS, non-solved DBMS, and the new-solved DBMS. These are the types of data you could expect in any business transaction in modern day. So, non-solved DBMS is designed to for non-relational distributed databases. These are suitable for large-scale companies, and it also has unstructured data. Examples are like MongoDB, if you have heard of it, Cassandra, etc. You have also object-oriented DBMS. This stores data as objects, integrates them as object-oriented programming languages. Uh, we have an example like ObjectDB. And the last one is the new SOL DBMS, combines traditional SQL with scalability features of NoSol for high performance and transactional processing. Example is the Google Spanner and the CockroachDB. That's all about DBMS. So what are the advantages of DBMS as we have gone through this? Who has a clue? What are the advantages of DBMS? Laureen?
It ensures data integrity.
Good. That's a good suggestion. Bernard?
It ensures data security.
Good. That's good. Chepngetich?
It ensures that there is not inconsistency.
Okay, that's good suggestion also. So it ensures data integrity, data security, data consistency, and its scalability. That's the most of the advantages of the DBMS. So if we are talking about a design process, we are designing a database. You will require some features, some processes to able to solve a problem in a company setup or in a database setup. Which, for example, you have here a logical design, physical design, conceptual design, and requirement analysis. Who can explain more about logical design if it's given a problem of a database of a logical design? Bernard?
Requirement analysis. Gather and analyze user requirements and data needs.
Yes. So requirement analysis is about gathering and analyzing user requirements for particular data needs. Thank you for that. I think now everybody here is able to understand what's DBMS, types of a DBMS, and now is able to design a database for uh, at the end of the day be able to design a database using the what we have learned above. So lastly, we are going to talk about entity relationship modeling. This is about designing. We have entities, attributes, relationship, and the cardinality. Can anyone try to explain us what's an entity? Yes, James.
Entities represent real-world objects or concepts.
Good. So entities just like something that represents something in the real world. Let's say a customer or a product or a service, certain service. What about attributes?
Attributes are the characteristics or properties of entities, like name or age.
Thank you for that. I'm very impressed for the things you have be able to to be able to notice the so attributes and the are the characteristical properties of entities. For example, if a customer has a certain attributes like age, name, etc. There's also a relationship between the attributes and the entities, which is depicted in an ER diagram. Cardinality describes the number of instances of one entity that can be associated with instances of another entity. So, so we are going to conclude with a case study or application in a real-world example, illustrative case study demonstrating the application of DBMS and database design principles in solving business challenges. Also, the challenges and solutions, discussion and scalability, performance optimization, and data migration strategies are implemented in accordance. The impact of how effective a database design and management contribute to improved application performance, data reliability, and user satisfaction. So thank you for being an attentive class. So I will give assignment on how everybody's going to design a database. The assignment will be linked in your emails. Yes, thank you and have a wonderful day.